Now we will get some more insights on how using Conan and why C++ is still a thing. Thanks, Ben, for joining us. The stage is yours.
Good morning. Yes, thank you, Roger. Yes, I am going to talk to you about Conan at scale. So first, a few bits of introduction and context. I'll introduce myself briefly. So I have a background in medical imaging, computational geometry, a lot of C++ architecture along the years, on graphical user interfaces, on completely automated processes as well. I'm most interested in tooling. So I'm all about removing manual tasks, all the toil that you can have, improve quality through repeatability, automation, that kind of things. I'm a software architect at Siemens Mobility now for 4 years. And I'm leading a small team of, well, it's called software engineering team, the SVEN team, in a project called Assisted and Driverless Train Operation Project. So, and mostly in a subset of that, which is focusing on obstacle detection. That team has 5 people in it. Our main goal is to improve development quality and create tools to serve quality, speed, so to make the life of developers easier, right? It's not because you want to improve quality that their life must become miserable. And the third thing that team does is assemble and code, I'd say, OS and middleware components that are helping this obstacle detection project. So what it is about this project, it's a quite large project. I'd say the obstacle detection alone has 70 people working in it. And what is it about? So let's say you have a train. It can be a mainline train. We want to put some sensors on it, looking forward and to the side of it to detect what comes in front of it. So to help drivers or to go to a driverless setup. And to do that, we need lots of sensors. So long-range sensors, mid-range sensors, short-range sensors. We need to blend all those signals together, have some algorithms that understand what is the situation, what are those objects, are they a threat or not, and then actuators that are deciding what to do with those obstacles. And what we focus on is this green part of the drawings there. All the handling is left to the future, but already you could see that we have lots of moving parts. And when you look at the whole dependency graph, it's not too big compared to some projects, but please keep in mind these are packages, right? So a package could have several libraries on its own. And this is the whole graph for our current application. And let's say most of those packages are done by one team, or each team should have something like 5 packages to deal with, and then they talk together, right? And that's what I mean here in terms of scaling up, right? So most teams in a small project that deal with 2-3 packages on their own, and then it's fine when they update one, they update the others, and they can manage that. But as soon as you have 4 development teams like we have, it becomes a bit complicated. And what is the most costly thing is communication between packages, and communication at different levels. So when you think about the developer scope, it's about sharing packages with others, sharing versions of a package. So what's new in a package, what is the problem with a dependency that you have, and you want to integrate all them together. When you think about it from the linker perspective or compiler perspective, or let's say from the machine part during your compilation tool chain, it's about loading symbols from a library, the right ones, right? Exporting them for your dependencies. And this requires a bit of tooling or a lot of luck if you don't have the good tooling, right? And that's where Conan comes in as a package manager. So it's a C++ package manager, although it could work for other languages, but it's mainly aimed at C++ or C and C++ dependencies. So it does 3 things. As any package manager, it resolves dependencies, right, across numerous and maybe conflicting packages. So it deals with versions, compatible versions, incompatible ones, notifies you when you have conflicts like this. Lots of package managers for different languages do that, or maybe also language agnostic package managers, such as APT or DNF, whatever. It handles also the configuration, compilation, and installation or deployment of packages. So for each dependency that you have, it can compile them as you go. So if you do not have a binary package that suits your development environment, it can compile it for you, which is quite handy in C++, where you have binaries that runs natively on your current host. So it's not as easy as having a non-compiled interpreted languages or languages that work on a virtual machine such as Java, right? So you need this configuration compilation step most of the time. But also it stores those recipes. So what Conan calls recipes or the scripts that allow you to build a package from source, but also binaries. So it has a whole mechanism to identify which binary is compatible for which running environment or compilation environment. And with those three things, you can do already a lot, but you can also extend it. And I'm going to talk to you about how to configure your Conan, how to extend it so it works well with a large team of developers or several teams. What this talk is not, however, is a Conan tutorial, so I'm not going to walk you through how to write your first Conan package or anything like this. There are already very good tutorials online. I will not spend much time there. It's not a how to get your build system or build system generator, if you talk about CMake, and Conan to talk together. It's a big topic of its own. We've worked a lot in that direction, but it's too detailed. You would not go far with just talking about this in an hour or half an hour. On the other hand, what this talk is showing you how to bring this multi-team, multi-package project to exchange this code effectively, right? And I will give you tips along the way on how Conan can help you with it, and how, well, it's a small concept you need to care about when you scale to multi-teams. Right, so I'll introduce how we work with Conan through the development pipeline that we have. To make it a little bit more concrete, I have here a view of how our applications work. So we have several applications, and they depend, let's say, if you look on the left-hand side on sensors and the right-hand side on, let's say, perception algorithms. And let's say we have a first layer, this MW there stands for middleware. So we have a middleware layer for sensors, for perception. So in our case, the middleware at the moment is ROS, but we would change it to something else at some point. We can exchange it. Then at the lower layer, you have, let's say, the business logic of a sensor driver or perception algorithms. Some sensor messages there. So it's what the middleware uses to communicate. You could think about it as MQTT messages or any other format that you know, but in this case, it's ROS messages. At a lower layer, for instance, for the sensors, you have an SDK that's given to us by the vendor. Usually it's not compiled, but it could be already compiled. We need to wrap it in that case. And it has its own third-party dependencies. We share data types between algorithms and sensors. So you see quite a lot of cross-boundary communication there. So if you're developing perception algorithms, you need to know about the data types that are sent to you by the drivers. You need to know the sensor messages that are published by your sensors, and so on. So whenever one of those teams wants to touch the data types, they need to communicate this change, whether it's breaking the API, they need to communicate this to the other teams. And this can become quite cumbersome when you have, let's say here, you have 5 layers of dependencies, maybe more sometimes. So you have dependencies vertically, let's say, and horizontally. So my first step here, when you start to work on this and add new projects, it's Well, whenever you create a project, use templates. If all projects look the same, then if you jump from one project to the next, if you look at another package, you will feel at home, right? At least this effort of getting used to what you're seeing is removed. If you've used things like cookie cutter for Python or other templating systems, this is exactly what I'm talking about. How does it work in Conan? Well, if you look here, we have some templates that we created. We can have as many templates as you want. And you do Conan new my package with a version, a few options there, and it creates a new list of files, right? With things that you value, like how to contribute to your project, what the license should be, a Conan file, which is the base file that you need to create a package to identify a package for Conan. Lots of CMake scripts in our case. And the templates are written using Jinja 2. It's also what is used in cookie cutter in Python, for instance. And what happens is, so you have a template with variables such as this name here or a version there, always surrounded by 2 curly brackets. And those variables are replaced at creation time with your actual package name or version. You can add as many variables as you want. In the command line, contrary to cookie cutter, for instance, you will not. It's not interactive, but you can have your own variables on top of the few default ones that are provided by Conan. Right. My second tip. So when you do configuration of a project, that's when you prepare your build scripts. CMake has this configure step, for instance, but lots of other build systems have it. You have this configure from AutoTools and other. This is usually when you create your toolchain, when you define which compiler you're going to use, on which platform you're going to work. So if you do cross-platform or cross-compilation, this is where this happens. And the tip is to control your compilation toolchain, right? So make sure that you can support and identify the toolchain for every developer that you have to help you control your binaries. So you don't want developers to build with any compiler if in the end what you do is an embedded system that runs on a single hardware with a single compiler version, right? So you may allow a few of them, but keep it in check, right? It helps you support them when they have a compilation error or linking error, and it saves you a lot of time. So to help you with that, Conan has profiles. So those are files that are stored in your Conan configuration that describe your building environment. So in this case here, we're going to build on Linux. It's an x86 64-bit architecture. We're building with GCC version 9 with C++ standard 17, and it's a release build. Right? We can also specify exactly which executables are used for GCC in this case. And as I said, you can have several. In our project, we have GCC from 9 to 11, debug or release, Clang from 10 to 14, debug or not. You can ask Conan about your current profiles. It gives you a long list there. You can inherit profiles. If I come back here, you can see here we include a boost profile. So it's where we also set a lot of options for compiling boost. Because let's say with the number of options there, if you let all your developers choose whatever they want, it becomes very quickly impossible to interact between different boost, let's say, flavors. So we help them with that, and it's quite handy to be able to inherit a profile. Right. So next step. So to help you with managing this developer environment, right? I said you want to control how they configure things. You want to give them templates, and we'll see later on. You want to help them package your different projects. And Conan gives you a config tool, let's say, so you can download a config. So all your users have to do is run a Conan config install something, right, with different type of locations. In this case, in this example, we inherit from, or we download from a Git repository. You can specify a Git ref, so it can be a branch, it can be a specific tag. You're not, I mean, my advice is also to provide your developers with containers where they can build and run your whole system, and you provide them with this config on them on those containers already. This is very helpful, but they can still do it by manually downloading this config. It's quite handy. Right, dependencies, the core of what Conan does, right? Declaring dependencies is quite easy, but I have to differentiate a few different dependencies, right? So this is a Conan file. So it's you have two ways of declaring dependencies, or to declare a package in Conan. You have a text file, which is quite declarative, or you have a Python script, which gives you much more power. So we use the Python script mostly because we customize a lot. And all you need to do is have a Conan file inherited class and some requirements. So first, this require line there takes either a string or a list of dependencies. Here we have a package that does logging, right? So it's a logging package that requires, it's abstracting loggers. And in this case, it depends on spdlog with the version 150. And here we have another type of dependency, how to inherit from other Conan file recipes. So this is a recipe, and here I'm stating that on the line 5, we are also depending on a Conan package called ADAS recipe with version 084. This means we also get a Conan package that contains a recipe here, and we use the second line, line 6, Python require extend, saying that we extend a class ADAS Conan file from that package. And the way it works is that it's more or less doing monkey patching of this Conan file, of this loglib Conan class, so that you get more featured or more customized extensions of the default behavior. This way, our users have very little to write in their Conan files, and they benefit from our infrastructure of development, let's say. All right. The second thing when you depend on packages is the versioning. Right? Versions are how you communicate changes to depending packages. Before I dive how we to how we work on versions, I need to tell you a bit about what are different entities in Conan packages. We have 3 different types of revisions or identifiers, let's say, for a package. First, we have the recipe revision, or what they call the rrev, for recipe revision. Very creative. This is just, let's say, a hash of the recipe file that you have. But you can change the mode that is used to compute this hash. And our advice there is to use SCM as a revision mode, in which instead of doing a hash of that file, you're taking the commit from where this recipe comes from. So this is only valuable if you're generating your packages from a known source, or I would say from a CI script, where you know that you're doing it from a clean repository. You're not doing it with unstaged files. You're just doing it from a known and shared state of the code, right? And the side benefit there is that when you look at this revision, you can directly identify it with a version of your code, because I mean it's a Git hash, and that is easy for you to retrieve. Right. Then there is something called the package ID, and that is not obvious at first. It's a combination of, let's say, platform information, architecture, compiler, build type. So something like would be stating it's a Linux, GCC5, debug. it tells you what is used to build the recipe revision, right? It also is combined with configuration options. So let's say you have a CMake project that takes configuration options, such as, I don't know, it sets a compilation definition to enable or disable some features. So what the package ID is some kind of a hash of all those fields, the architecture, the compiler, and the configuration options. It means that with a pair of recipe revision and package ID, you should have a binary that is compatible, right? If you build it twice with those things, you should get the same package. And finally, you have a binary package revision, or the prev, which is simply a hash of all the installed files that you have when you install it. You would say, well, I do not need the package ID and the recipe revision to build if I have a binary package, right? Well, if I have this prev, I'm okay with it. Well, it helps you find those binary packages faster, for instance. And also, maybe sometimes you have differences in your binary package, but you don't care if they have the same package ID for some reasons. You may have configuration options that you want to ditch from your package ID, and I will show you this later. Now I want to tell you about the version use cases. So we talked about having versions with your packages, but how you use those versions varies a lot during your development process. So the first use case is you have fixed releases. So you know that you have a certain state in your software, you've tested it very thoroughly, it's gone through some validation process that is not just your unit testing, but any validation you can think about. And so you pin those versions, they're there to stay, they're, let's say, etched in stone, they are fixed releases, first case. Then you can use continuous integration of release trains. Right? Let's say if you use semantic versioning, I really encourage you to use semantic versioning in C++ and use it strictly. So really make sure that your ABI and ABIs are, let's say, broken only at certain levels of your versions, right? So major versions, they break API and ABI, or minor version add to the API, but do not break it for other dependencies, let's say, and your patch versions don't change the interface or the API. Right. And this is helpful when you want to inherit from some minor version, let's say, and never update your recipe and always get new dependencies as they come, right? And the last case is when you want to use experimental code. So you want to depend on a work in progress kind of dependency because you're in charge of 3 packages and you want to change something at a lower level and you want to see if it behaves correctly at your higher dependency level. And so my tip there is to always provide a blend of those 3 ways to handle versions. So the release versions are pinned and locked, moving aliases so that you can, by pointing at a single identifier, get new versions of it without touching your code, and temporary non-released version. And here I really insist on the temporary because so you want to delete them after some time to make sure that your users are not depending on them too much for too long, and encourage them to release often to have those known steps instead of having half-baked dependencies in their hierarchy tree. Right. So this is an example of how we do versions in Conan. So here I'm showing you what is the version generated by Conan. It's not the version that you have in your CMake. I mean, it may use the one from CMake, for instance, but it also, in this case, uses the CI, some CI knowledge to know what to do with this version. So if we release, it's a tag, it's 010, that's it, nothing to do. If you have a release candidate in a branch called rc/something or release/something, then we add the pipeline IID from GitLab CI, because we use GitLab in our CI, and then some short SHA-1 from the integration. And for example, this gives us a 020 RC12 plus some hash. The pipeline ID here is very convenient because it's a monotonous number, so it goes up with each build, and so it helps you ranking what is the newest, what is the oldest version of anything that you've built. And then we have an alias for this because it's a release candidate. We know it's more stable. So if you depend on 02 RC in your Conan file, then you can update it to the latest progress there. We do the same for stable development versions that are on the default branch. And then for temporary branches, for what we call feature branches and hotfix branches in our case here, we use the same schema with the pipeline IID, the short SHA-1, and then the alias is different. We put the name of that branch in there as well, and we clean them quite often. All right. How do you build? Right. So I said you need to control your binaries, and you want to make sure that your ABI is what you want, that your package ID reflects building options and your building environment. And Conan helps you with that, right? So I already talked to you about those platform, compiler, build time, architecture. So you can use any subset of them in your Conan file. By the way, this is an extract of our upstream Conan file, the one that was inherited from earlier on when we were inheriting from other Conan files. You could imagine that you do not care about the architecture if what you're building is a Java application. You could do that, for instance. It's quite flexible. And then we've added ourselves, for instance, this distribution. So we're saying that in our binary package, what's important is which distribution it's been built on and what its version was. For instance, we've had a problem with Debian from 10 to 11, I think. We had a change in the libstd C++ ABI, and suddenly the binaries were not compatible. So either we found a way to identify which libc++ version was used or which standard library was used, or what was the native one on each of the distributions. We went for this because it was much simpler and it worked well enough for our cases, but well, your mileage might vary. And in terms of options, so we have CMake options on PCLP, that's a static analysis tool, enabling or disabling the testing, enabling or disabling documentation, a certain coverage threshold. Those are not influencing the binary package in the end. So we exclude them from computing this hash for package ID. So I encourage you to do that kind of thing, to tailor your package ID to your own needs so that you don't rebuild packages all the time. So having a compatible package ID allows you to not rebuild packages when you already have them in your cache, basically. And so it saves you compilation time. Then Conan gives you hooks. Well, here we use this. We can use it for many things, but basically to extend functionalities in Conan. But in our case, we use this for quality gates, so quality enforcement. And the pro tip here is to, well, use automated tools as much as you can to enforce quality, because the earlier you find those problems, the better. And if you run your quality checks at each CI run, and people know them early, they learn them, and it goes in their mind much quicker, and the development is, well, I'd say, benefiting from people who learn the quality rules and do not forget, typos and whatnot. So the hooks there are Python function that you run before or after getting the source code of a package, after building it, or, well, at build time, packaging it, and so on. And they are shared also in this Conan config, so you can share them between all your users, and they're package independent, so you use the same quality rules for all your projects. It's also a very good thing. I have some examples there, but I'll go quickly through selected ones. We have a license checker to check if you really have a license in your project, if you do not use the template to create your project, for instance, or if you change the license in between. We have a naming convention checker. So this one is interesting because it takes advantage of the CI environment variables to check that your repository name matches the package name. That's quite handy. It's very easy to do a small typo there. We have version checkers to check that we're using semver, also semantic versioning, that the version is based on the tag and so on. And we have lots of them there. It's quite free. We could have done it all in CI. In this case, we've done quite a few of them in the Conan hooks. One of them is very interesting, is checking that all your dependencies, this here, all your dependencies use only released versions when you have a release tag. So if you're trying to release something, check that all the dependencies are not based on those temporary, untested quality that you don't know about, that kind of thing. So I've talked a lot already. I can now wrap up a little bit what I've presented. So there are a lot of things that we could not talk about. Right? There are things we don't use in our team, like Conan workspaces. They're quite interesting, I'd say promising feature. They are experimental at the moment that help you work on multiple packages at once. They're a bit like editable installed packages in pip, right? When you install it, but you can still modify them and see the result when you rebuild the whole thing. Conan version 2.0, we're working on it. It's going to be a big change. It should simplify our work, but we'll see. There are other things that we don't understand or we don't agree with. That's where we're going to most probably contribute back or interact at least with the Conan people there, because we have experience with this, let's say, large set of projects, and we want to make it easier on that specific use case. Lots of things that we use in the team. ROS2 integration with Conan. So Conan is a way to build ROS2 packages. So ROS is the robotic operating system or robot operating system. I don't remember. It's what we use as middleware, as I mentioned earlier. It's quite complex because we're trying to integrate two meta dependency manager build system projects. We have quite some problems with it, but we've gone a long way with that. Conan generators, you can generate, in fact, you can even generate packages on like APT packages or whatever you want. It's a huge topic as well. How to interface your CMake libraries or script with Conan. How to use virtual environments. So you can use virtual environments in Conan the same way you do it with Python. For instance, if you just have binaries, or I'd say results that you want to interpret, you can pop up a Conan environment with the dependencies that were used to generate this data. And finally, yes, how to, let's say, work hand in hand with CI script and Conan to orchestrate all I just talked about. It's also a big topic of its own. So all the tips I gave, there's a short list of them. So always use templates when you create a project. Control your project tool chain. Upstream as much as you can so that your users don't need to pay attention to all your rules that help them in the end. Versioning, use 3 types of versioning. So released versions, moving aliases, temporary non-released versions that you can download binaries or source. And enforce quality through automated tools, and use hooks for this in Conan, for instance. You can do it with any other way, but those are making you go a long way in terms of scaling up with multiple teams. We've learned quite a lot of things. So as you all may know, if you are in modern days, you should treat your infrastructure as code, your CI as code, and also then your build system generators and package managers as code. And so that means you should write tests for them. So we did that. Even then, you end up with lots of bug reports from your users, but having tests allows you to not go back on errors and not make them second time. Yes, system-wide installation or a thing of the past now, even for C++. It's been a thing of the past for Python users, well, in some way, Rust, Node, whatever, and now C++ can do that too. Conan is not the only way to do package management, but it's a damn good one. And finally, balancing what configuration you put in your CMake file and in your Conan file is still an art. You can put as little as you want in your CMake and as much as you want in your Conan, but where you put the cursor is for you to decide, and we don't have the magic bullet yet. So we're still learning there. And finally, I want to thank the Stand team members from the past and now, so who helped us write all those Conan recipes and define our version rules and whatnot. And also the Code Siemens Con team, right, who provides us with this wonderful CI environment, and in this case, a Reveal MD template that I could use to generate this presentation. Right. And with that, I am done, and I'm ready for your questions.
Thank you, Ben. We have some question here from the chat. The person asked, we also used Conan 2 or 3 years ago in our project, but we struggled a lot with the immaturity of Conan. For example, no hashing of the packages, but only generic string versioning. A big problem was also that a lot of OSS libraries were missing the support for Conan integration. Has this changed so far, and what's your mitigation for the maturity?
So it changed a lot, definitely. It got way better. We're hoping a lot on the version 2. At first, we had lots of workarounds to go through. So that's why we ended up with, well, that's where you start looking at the package ID and all those things, right? And you tailor it to your needs. I'd argue the default settings are not good enough for large projects, but the defaults are sane for smaller ones in any case, at least now. As for dependencies, the Conan center is becoming bigger and bigger. It's true that sometimes we choose one dependency because it's in the Conan center, but we have lots of third-party dependencies that don't have Conan script, and we write them ourselves. We have our own Conan repository using an Artifactory instance that Siemens provides us with, and that allows binaries and recipes. So we have our own recipes for some projects, and we store the binaries, for instance, for Boost. We also store the binaries that work for our project, because then we save a lot of time for everyone. And yeah, I'd say it is changing every time. So every couple of months or so, we update it, and it makes our life a tiny bit easier. I'd say it's definitely production ready now. Always getting better. Yeah.
We have one question here, audience.
So how does this approach integrate into embedded systems where I have shared libraries which are shared among multiple components, and I only want to have them in one particular version, like with distros, what you currently have?
Yeah, so that's exactly what it's for, right? That's what we use at the moment. So if you go back to first here, I'll give you the dependency graph. Yes. We have pinned versions of all our dependencies there, right? And we've made it so you have lots of dependency policies. We could say that we allow different components to depend on different versions of the same library. So for instance, here we have eigen. We could say that this package depends on eigen 3 something, and this one on another one. But what we've made sure here is that we specify that we want the exact same version for all the dependencies. It allows us to control better what we have in an embedded system. It also helps you with clearing of your dependencies and handling security threats, because then you have only one version to care about. And that's that. Compared to an APT repository, so APT works well for you use this on a system-wide way, So you install only one version of everything. With Conan, you could also have, let's say, a virtual environment and really segregate the things differently. It's another way to handle multiple versions on a same system. Yeah, I don't know if I answered your question, but that's what I have for now. If you need more, you can precise.
We have another question from the chat. What are your thoughts about VC package compared to Conan? So that's a Microsoft
So I've
created
never
C++.
used. Yeah, I know it. I've never used it because well, we only use Linux in our embedded software. So I know there is a. I think there is a port of VC package on Linux, but yeah, I've not used it, so I cannot really tell you. What I know maybe is that yeah, Conan is very extensible. We've tailored it a lot. You can tailor it as much as you want. I don't know if VC package has that plasticity.
One more
Any other
question
question?
here.
Just so you mentioned the workspaces, and I think I looked at this a few years ago, and it was also kind of not mature. And for large teams that might want to, yeah, like you said, work on a library and its dependency. So right now, there's no good alternative. I guess you just really have to, push, wait for CI, use it, and so you have this loop. And
yeah, so the workspace feature is not mature. So it was developed a few years ago. It seems that for Conan version 1, development more or less stalled, and maybe better with Conan 2. We have not looked at it for some time because it was not production ready for us. This is it's a bit of a shame because when you have this depth of hierarchy in your project, yeah, at the moment that's what we do. We use the CI heavily to generate things, and I mean you can also do it locally. You can work with 5 different packages locally. That's just as good, right? But you manually do Conan create and export and reuse it from your other packages. It's a bit of manual intervention from the developers. It's a bit of a shame.
right, thanks.
Perfect. Thanks a lot, Ben, for joining us and providing all those insights on, so we learned that Conan is ready for production and it's used in a real environment. And I wish you all a nice lunchtime.
Yeah, thank you everyone for listening to me. And I'll be hanging around the virtual bar later on today. So I'll meet you there.